Hey guys, Andre Freeman here. All right, so we're going to do a problem which involves using a sample proportion to estimate a population proportion via a confidence interval. So the problem says that a March 2020 poll conducted by CNN reports that 48% of US adults believe that the federal government has done a good job in preventing the spread of the coronavirus. The poll was conducted March 24th to March 29th. Let's assume that this sample proportion is from a random sample of 400 US adults. Create a 95% confidence interval to estimate the proportion of all US adults who believe that the federal government has done a good job in preventing the spread of the coronavirus. We can follow these 5 steps below, and we want to begin by determining the sample statistics. So the sample statistics will be the sample size and the sample mean. So in this situation, the sample size N would be 400 US adults. We're assuming that the sample is from is random, so it's 400 random adults from the United States population. And then we have the sample proportion. So P hat is sample proportion, and we're told that the sample proportion is 48%, because this poll that CNN is reporting is basically a poll from a sample of adults. 48% in this situation is not the population proportion, it is the sample proportion. The population proportion is unknown. So we'll use a confidence interval to estimate it. All right, so this is the first part. The second part says, are the normality criteria satisfied? So basically what we're saying here is, from a mathematical standpoint, are the sample proportions from random samples of size 400, are they normally distributed? If we think about all possible sample proportions from this population, will the proportions be normally distributed? In which case we can use a normal model to represent them and also find probabilities. So we're going to check 2 criteria. N times P hat. This should be at least 10. And then this will also do N times 1 minus P hat. Basically, what we're doing here is we're determining the number of successes and the number of failures. A success in this case is a person in the sample who says, yes, I think the federal government is doing a good job. A failure would be a person in the sample who says no. Remember, the sample has 400 people. So the number of successes will be 400 times 0.48. And this is going to give us 192 people in the sample who said that they think the federal government is doing a good job preventing the spread of the virus. Now, this is, of course, is greater than 10. So this is satisfying the criteria. The next check will be N times 1 minus P hat. So this will be 400 times 1 minus 0.48. And again, there's 400 people in the sample, so we can use that to our advantage to determine what this result should be. This is equivalent to saying 400 times 0.52, and we're going to end up getting 208. The sum of these 2 numbers must be 400. So this is basically the number of failures, the number of people in the sample who say no, they don't think the federal government is doing a good job preventing the spread of the virus. So both of these are greater than 10. So because of the fact that both of these values, again, number of successes in, sorry, that's not it. Try that again. The number of successes in the sample and the number of failures in the sample, both of these are greater than 10. So the normality criteria are satisfied. Okay, so let's compute the margin of error. So the margin of error is going to be based on the formula E equals Z sub C times the square root P hat 1 minus P hat divided by N. You don't have to memorize these formulas, but you want to make sure that you're comfortable using them. This is the formula for the margin of error for an interval estimate for a population proportion. Notice that P hat, of course, is a sample proportion because we don't know P, the population proportion. We're computing this for a 95% confidence interval. Using the normal distribution, 95% confidence, this corresponds to a critical value, Z sub C, of 1.96. And you can look at your notes as well as some of the tables to determine critical values for levels of confidence based on the normal distribution. All right, so we end up with the margin of error is 1.96 times the square root of 0.48. 1 minus, so this is 0.48. 1 minus 0.48 would give us 0.52. The sum of these two probabilities or percentages should always be 1, and divided by the sample size, which is 400. The margin of error, this is an important value in this process. So this is going to give us 0.049 rounded to 3 decimal places. And typically you want to round the margin of error to 3 decimal places. So one of the ways that we can interpret this is that 95% of sample proportions from random samples of size 400 will be within this distance from the population proportion. I'll say that one more time. Again, 95% of sample proportions from random samples of size 400 will be within this distance from the population proportion. So we're going to basically apply this distance to the sample proportion provided to get our interval estimate. So the interval estimate is going to be p hat minus e and p hat plus e. So these are the limits. We basically take the sample proportion of 0.48 and we subtract the margin of error, and we take the sample proportion and we add the margin of error. So we have 0.48 minus 0.049, and then we have 0.48 plus 0.049. We end up getting an interval estimate of 0.431, which would be, as a percentage, 43.1%. And the upper limit of the interval is 0.529, which as a percentage would be 52.9%. So right now what we can conclude is that this is essentially our 95% confidence interval for the unknown population proportion, which is the proportion of all US adults in late March who believe that the federal government is doing a good job preventing the spread of the coronavirus. So this is a 95% confidence interval. It is certainly possible that the true population proportion is not inside this interval, but we have 95% confidence that it is. So we can, assuming that the sample was representative and random. So we can conclude that we are 95% for the interpretation. We are 95% confident that the proportion of all US adults who believe that the federal government is doing a good job, oops, missed a word there. Is doing a good job preventing the spread of the virus, the coronavirus. Is between and let's write this as percentages, is between 43.1%. We can also write as proportion, but let's write it as a percentage, and 52.9%. So we can certainly see that given our interval estimate, we don't think it wouldn't be reasonable that 60% or a proportion of 0.6 of U.S. adults believe the federal government is doing a good job, because 60%, or the proportion 0.6, is outside this interval. This interval certainly contains the proportion 0.5, or 50%. So it's reasonable for us to think that half of all U.S. adults believe the federal government is doing a good job preventing the spread of the virus. So this is the process, guys. It's pretty straightforward if you do enough of them. And make sure, again, you understand these 5 steps, and you're careful with your calculations and think carefully about the interpretations.